Hi, my name is Trevor Best, and I'm the CEO of Syzygy Plasmonics. Let's talk about transportation fuel like gasoline. It has been made the same way for the past 100 years. First, you take a fossil fuel feedstock, something like naphtha or natural gas, and then you burn it to produce a lot of heat, and you use that heat to power an enormous reactor. These reactors are the size of this room we're in. You use that reactor to create something like gasoline, and then you transport it to the point where it's finally used. Now, there's three problems with how fuel is made today. First, emissions. These processes in the gasoline that is consumed by people every day are responsible for gigatons of carbon emissions every year. The cost of gas sets the price for almost all other commodities that we use. It dramatically affects it. And finally, the centralized production model is starting to show its age. You're starting to see industries like manufacturing move to a more efficient, distributed production model. I'd like to introduce Syzygy Plasmonics. We are developing a completely new type of chemical reactor for fuel production. Our technology reduces both cost and emissions from fuel production by 50% or more. Not only that, this chemical reactor is a platform technology. In our lab, we've used it to make ammonia, which is a base for fertilizer, ethylene, which is a base for plastic, methanol, and many other chemicals that we use every day. Now, possibility is great, but as an early stage company, we have to focus. So the first product we will be bringing to market is a small-scale, distributed, point-of-use hydrogen production system. Because it is using our reactor, it is able to reduce both cost and emissions by 50% or more. Because it is deployed on-site at the point of use, it completely eliminates the centralized production model and the very expensive supply chain associated with getting fuels to the point where they're consumed. Now, you might be saying, wait, I thought we were talking about fuel. Why hydrogen? That's because hydrogen is an ideal transportation fuel. When you run a hydrogen fuel cell vehicle on hydrogen, the only emission out the tailpipe is water. That's why you see a myriad of applications starting to arise. Today, there are hydrogen fuel cell forklifts, boats, planes, trains, Class 8 trucks, passenger vehicles, drones, you name it. You're starting to see industries commit, with Walmart and Amazon both adopting hydrogen fuel cell forklifts in their warehouses, Hyundai working with Switzerland to deploy 1,600 Class 8 trucks over the next few years, Norway committing to 1,000, the Port of Los Angeles starting to switch their fleet over to hydrogen. This is happening today. So when I tell you that Syzygy can reduce the cost of hydrogen for these users, what I'm telling you is that we can reduce the cost of hydrogen for distributed applications from $6 to $20, where it's at today, down to $3 to $5. That 3 to 5 number is extremely important because at this price, we can make hydrogen hit parity with gasoline. So that is what Syzygy is working for, to give the world an economically viable, low-carbon alternative to gas. We don't need to play any funny games and get ultra-low-cost electricity or anything like that. We can do this with standard grid electricity, standard cost for all of our inputs. Not only that, our system will be much lower cost, much easier to maintain and operate, and it is ideal for many of these applications. We already have significant demand. We're talking to Fortune 500 companies in the energy space, in the fuel cell vehicle space, and industrial gas suppliers. They're interested in us because the speed at which we're moving. We've scaled up our technology more than 10,000 times since the beginning of 2018, and we're working to continue doing this and get a product in the market in about 2 years. We're supported by a world-class team. Myself, I do the business. My co-founder, Dr. Suman Kadiwada, he manages the technology development, and the 2 professors from Rice University who developed this technology. So the technology is very well validated. Speaking about the professors, they've spent the last 20 years researching a field of science called nanophotonics, specifically plasmonic photocatalysis, which enables us to do what we're doing. This has been published in leading academic journals of science and nature. And we've also been the recipients of a Department of Energy ARPA-E award. This is one of the most prestigious grants for energy technologies that you can win. We had a team of PhDs from the Department of Energy come in and really put us through the ringer. And at the end of that, we got a handshake and a check. And just to mention again, we can make more than just hydrogen. Hydrogen is just the beginning. So once again, we are Syzygy Plasmonics. We are trying to give the world a low-cost, economically viable, emission-free alternative to gasoline. And we are raising a round. If you're interested, come talk to me, and I would love to take any questions that you have. So we have two alternate production paths to make hydrogen. One is from ammonia, which is NH3. This is a long-term solution that we see can be completely carbon-free. The other is methane, and so it is photocatalytic steam reforming of methane. This is not completely carbon-free, but when you run a vehicle on that hydrogen, you get about an 80% emission reduction well-to-wheel.
Hi. Thank you for your presentation. One of the issues with hydrogen as fuel is that you can't outrun a hydrogen fire. So that's where APUs, auxiliary power units, come in as a competitive technology. So what are your thoughts on safety?
So there's been a lot of work on safety. I'd love to send you some materials. Hydrogen is actually comparable to gasoline in safety. You know, if you light a gas tank on fire, it explodes too. We've just gotten very, very comfortable with that because we're around it every day. They've actually done some studies where if you shoot a hydrogen tank with a gun, it does have a flame, but it doesn't explode like a gas tank does. So it's got a bad rap because of the Hindenburg, but tremendous strides have been made, and hydrogen is quite safe. Thank you very much, and y'all have a great day.